Okay, so this is a very cool question. The reason why this is a cool question, if you ever graph it, is actually pretty interesting. So I'm going to show you on Desmos how do I graph this. Okay, this is, by the way, this is other graph. So here I got x squared minus a squared. So and parenthesis divided by x minus a. So we have this question. We have a here. We also have another one is there is a coordinate. At a, there is a output of 8. So this red dot right here, right? Now, if you pay attention, when I go underneath that red dot, I'm going to see an open circle. Do you see that open circle? Do you see that? Now, if I move this a little bit different, let's say move to 2. Okay, I can't really move to 2, but if you go to here, if you see that there is a probably not. Do you see the open circle or no?
Yeah.
There's an open circle, right? See that a line where the red line is? So you know this open circle is kind of sliding through from one spectrum to the other spectrum. There's only one moment in time that where the red dot is going to fill in the blue open circles. So if you go into here, you're going to see that this part is the one that is going to fill in. So if you slide around here, it's going to still be open circle, but it's going to be filled in by that red dot. And that's how to make that function continuous. So those are actually pretty interesting situations. With that being said, I do want to use this question to review what makes function continuous. First, for function, how do I make function continuous? This is on the test. F of what? F of a is defined. Now let's check f of a is defined or not. In this case, is f of a defined? F of a is equal to a. So is defined, right? Does that make sense? B is limit x approach to a of f of x is equal to exist. Okay, so let's go to B. So limit x approach to a of x squared minus a squared over x minus a exists or not? Well, it does exist because limit x approach to a of x plus a, x minus a over x minus a. And x minus a cancel, that's equal to 2a. So it does exist. Does that make sense? C. What does C says? Limit as x approach to a of f of x must equal to f of a. Well, that's just going to be 2a is equal to 8, a is equal to 4. And that's it. Pretty cool question that's gonna using that to talk about if the function is continuous at one point. It's actually very, very interesting. Amir, did that answer your question?
Well, how do you do part B then?
Part B, I just do factor because I know it's 0 over 0. So if it's 0 over 0, I have to factor and cancel. So it'll be x plus a times x minus a over x minus a cancel out. Now I'm gonna plug in the x as a, right? Whatever this x right here, I'm gonna plug it as a. So that's gonna give you 2x. It's a very interesting question. I think a lot of people like, let's talk about two things at once. Talk about you know how to use limits, and talk about other things. Questions?
Wait, for C, did you say f of x equals f of
C. F of x is equal to f of a. Yeah, those are the things I will ask on the test. Just like this. What makes function continuous? You have to have those 3 requirements. And this is going to be a test question over and over and over and over again, except they don't ask you to memorize it. They actually use how to apply it. In the first test, I'm not going to ask you to how to apply it. I'm going to ask you to memorize it first, and then later on you can learn how to apply it. This is a perfect question to apply it, and that was a best thing for this questions. Any other question to go over? Yes. 95. Okay, so 95 is also a question on the test. So 95 is it says f of x equal to x squared. What is it? Plus x minus what? 1? Okay. And they say f of c is equal to what? 11? They say, oh, Joe haven't shown up for a while. No.
Only 2 days.
Only-
Yesterday.
Only 2 days. Yeah, for Joe, that's very minimal. He don't show up a week at a time. Tomorrow you probably show up.
When we have a test.
Uh-oh. Maybe. Okay, so in this particular case, right, f of x equal to x squared plus x minus 1, they just want to ask you to use intermediate value theorem to prove it. Intermediate value theorem will be on your AP exam as well will be on the test. So in this question, in the problem, they actually want you to find C. On AP exam, they don't ask you need to find C is. So basically, it's between 0 to 5. So first thing first, what's the first requirement for intermediate value theorem to work? Yep, the function is what? Is this function continuous? Yes, because all polynomial, you're going to say all polynomial is continuous, especially between 0 to 5. Now, even you have something like 1 over x minus 7, x minus 7 will still be continuous because only at 7 is discontinuous in this particular question. So even if your f of x is 1 over x minus 7, it still would have been fine because it's continuous in the intervals. Does that make sense? So B says f of A does not equal to FB. So FA does not equal to f of B. Let's see if it's true. I'm going to plug in f of 0 first. If I plug in 0, I'm going to get -1. F of 5 is going to be 5 squared plus 5 minus 1 is equal to 29. So f of A does not equal to FB. C. It's k between 0 to 5. Yeah, k is going to be, C is going to be between 0 to 5. That's true. But it's f of A in between f of C in between f of B. Yes. This is 29. This is f of C, which is 11 and less than -1. So it has to go through 11. So if you have those 3 conditions, write it down. You can say intermediate value theorem. Proof. There is C where f of C is equal to 11. Because it has to, from -1 to 29, it has to go to 11. And this is how you write it down. Now, if you want to find C value on this particular case, you can. So they say C squared plus C minus 1 is equal to 11. So it'll be C squared plus C minus 12 equal to 0. C plus 3. No, C plus 4, sorry. C plus 4 and C minus 3 equal to 0. C equal to 3 and C equal to -4. So this C equal to 3 here is where f of C is equal to 11. Now, normally, I won't ask you to find out where the C is. On AP exam, they don't tend to ask you where the C is. They only ask you, can you use intermediate value theorem to prove that there is a C value within? It's like a drink of water in the very beginning of the day and end of the day, it must go through that label. Any particular questions? Did I answer you on this question, Foley? Those 2 on the test. Yes. Yeah, but I understand the ideas behind it. I mean, whether you can, not a lot of people can write math. A lot of people can do math work, but not a lot of people can write proof. Proof is not one of the things that is very popular according to this new age students. But you got to write a minimum says you had to prove that f of 0 is equal to -1, f of 5 is 29, and it's continuous. There must be a c value where f of c is going to go to 11. Write simple thing. You don't have to write the whole thing, but this is what I would write on my test. But a lot of time I give you most of the credit if you have enough stuff write down. Just like AP exam, you gotta write down something that has to be there. For example, testing the endpoint, that's something you have to know.
We have to know everything. Estimated value theorem proof as well.
What a proof? Yes, because you just have to say all polynomial is continuous between intervals. You test in the endpoint, it must go through 11. Therefore, yeah, you can say intermediate value proof. I can give you a question that f of c is equal to 30. Then you're gonna say, well, intermediate value proof does not prove that there's a c in between. That's what you had to write on the statement. So a proof has to accompany with a statement. You have to learn how to write down the statement. Do you know how to do it now, Jared? Cool. Asim show you? Next question. Okay. You're gonna do 13. What is it? 132? It's right here. This is question 132. For me, I write down a statement where the breaking point is. Michael did send a video yesterday, Michael Remington. He said this is a video that helped me, which is fine. You should always look up the video that will help you, whether it's my video or other people's video. The person on the video, I actually go skim and see if it's a good video or not. I want to see if it's reliable. And it seems pretty reliable. And I'm okay with that, as long as you find some resource to help you. It doesn't matter which video you go to. My video is more particular to your class. So like I just did a video about this class. Basically, I'm going to look at the point of interest. The point of interest is going to be happen at -1, there's a breaking point. Also at 1, there's a breaking point. For -1 and 1, there's a breaking point. So I'm going to approach -1 from the left side and -1 from the right side. Why do I write down limits? Now, if I don't use limit, I just plug in. But the problem is technically you cannot plug in. And I'm going to explain to you why. Ron Grudge yesterday at 7 period says, what if I approach 1 from the left? And 1 from the left is going to be this equation right here, because 1 from the left is going to be this equation. But however, if 1 to the left, you cannot just plug in 1 because they say less than 1. So if it's less than 1, you can't really plug in 1 technically. However, instead of plugging 1, you can do the same thing, use limits. If I say limit approach 1 from the left side, which is going to be like this, eventually you're still plugging 1 for x, but using limits instead. Limit, the first thing about limit is plug in. So you're not really plugging the value, you're approaching the value in particular way. So this is end up to be a great question to talk about that. This is the reason why I use limits. Some of you guys probably didn't use limit, probably just plug in. And you don't understand the fundamental differences. If an FRQ on AP exam, you have to use limits because limit is what they're gonna want you to do, to plug in. So this graph will end up to be something at -1 and 1. There is some type of breaking points right here. I don't know how that is, but there was a breaking here. So I want to approach from the left and right and from the left and right. And this is how I write my statement here. Limit approach -1 from the left. I'm going to use this equation as opposed to any other two equation. because when it's less than 1, you have to look at the restriction. This is only one is less than 1. And I'm going to use that equation. I'm going to plug in -1 from the positive side. I'm going to use this equation because -1's right here from the positive side because this is x greater than -1. This is where I will create this first statement right here. Any question about that first statement? Any question about the second statement? The second statement is 1 from the left and 1 from the right. But it's not -1. This is 1 from the right and this is 1 from the left. And again, I use limit to approach that. Because technically you cannot equal to 1 from the left. When I set them equal to each other, I just plug in the x. X cubed is -1. So end up this becomes negative sign. And this is a -1, so this one becomes -1. So negative m. And again, this plugging 1 here, look at here, plugging 1, look at here, plugging 1, and this plugging 1, it's going to get this. Now I just end up to be k is equal to -3, and the m equal to -k, therefore this is the final answer. Now, usually it's going to be system equation. I would say on the test, you're going to see a system equation. So you have to know how to do a system equation. Jerry is doing that Algebra 1 packet right now, and I asked her how to do a system equation. Guess what? If you know system equation, it'll help you on SAT. Elimination, substitution. There are usually 2 questions on SAT. One is a word problem. One is just straight out elimination. And the word problem is going to be like Johnny's buys like 3 sodas and 2 popcorn and $20. And Yazil buy 5 soda and 2 popcorn is equal to $30. How much is soda? How much is popcorn? It's going to set up that way or set up a different way, which is total price and total tickets. That's another way to set up. So you have to be familiar with that. I already told you before, when you take this class, I want you to improve your SAT score. Usually, yes. Indirectly, you should improve roughly 100 points. If you do everything I asked for. So this is better than any prep class out there. Prep class is going to charge you almost $1,000 for Kaplan's or $2,000 for Kaplan and doesn't even guarantee that much you improve. If you strictly religiously do what this class is supposed to ask you to do, I will talk about elimination, substitution is definitely on this SAT exam. This is a question you have to get it right. Okay, any other questions? Yes.
97.
97. Unfortunately, you cannot find C on that particular case. You can only plug in to figure out because there's no way to factor that if you're trying to find C. But there, I just wanted to prove that C actually occur. So you're going to do the same thing on 95. But you don't have to find out what the C is. The only way to find out C is to plug in random value from 0 to 3. And the only value that makes sense is 2. And there's no way to factor that because not that I know of. There's the other way to do it. And sometimes there was some tricky way that I know, like there was a YouTuber named Blue Pen and Red Pen. He does a very interesting factoring skills, and those are the skills I don't actually possess. But he does actually a very interesting thing that he can factor some weird things that he cannot factor. But there are so many tricks you have to remember, so it's almost not worth it. Yes.
So can you explain why you have to do limits on that again?
If you pay, good question. If you pay attention, let's say limit approaching 1 from the left, right? Technically, you cannot just plug in 1 because you're plugging 1 because x does not equal to 1. But we can approaching 1. Because x is less than 1, can I approach 1 from the left side? So therefore, I use limits. But limit is still the first step is plug in. So it's another way to get around it. Limit is like assume that you can get there. But you don't. You have to assume, so make sure that you have to pretend that you are there already. So then you have to plug in the value. So you have to use a limit instead of plug in. The plug in is you actually can plug, technically, you cannot plug in 1 into this equation. That's not legal. You can plug in 1 into this equation because the x greater equal to 1, but not the other side. Amir, does that make sense? Okay. Yes. Let me see. I don't think that's right answer. Hold on a second. Oh. That looks right. Okay. I need you to be number 9. Last question. All right, next question. No other questions? All right. So let me end my stream here.